Could you guess the next one we're going to do? Yeah, okay, so what do we need for homogeneity? We need a scalar and a vector. Consider the 2 norm of A times X. Why can I say that's times? A is a scalar. Let me ask you this. What do all Tor norms have in common? What's the thing on the outside of the sum of the squares? Square root. Beautiful or ugly from the standpoint of algebra? Hideous. What's one way we can get rid of square roots really easily to start with? That's a hint. Anytime you work with 2 norms, my hint is do it all without the square root, and only at the end of the analysis bring the square root back in. Okay, here we go. What's the 2 norm of this thing squared? Well, let me ask you this. Let's do a side note real quick. A times x, which is a scalar multiplication with the vector x, what would that look like? This is x1, x2, all the way down to xn. What does a scalar vector multiplication do? ax1, ax2, all the way down to axn, which means if I take the square of the 2 norm of that vector, what happens? The square of those elements. So now I've got a times x1 squared plus a times x2 squared plus a times xn squared. Okay, what's that? Yeah, distribution, usually when you say distribution to me, I hear multiplication over, but I get what you're saying though, pass it out, right? So a squared times x2 squared plus what's the last one there? Oh, yeah, thank you. All right. Do you see anything that's common there, Yanru? A squared. So what could I do? I can hear Jay Zing, bring it out, Jay-Z's singing to me right now, right? That is a real song, right? I'm not just imagining that. Yeah, thank you. All right, so let me ask you this. What would then happen if I took the square root of that?
You have the square root of that.
Yeah, that's right. Plus all the way down to xn squared. What do we know about square roots and multiplication?
Would you have a plus or minus in the front by 10?
Well, okay, so assuming that we've established that the 2 norm is always non-negative, do you need a plus or minus in the front? Why not? Because the thing in front of it is always positive. This is never negative, right? Okay. It's always positive as long as the thing inside is not 0, right? So do I need a negative in that case? Never, because then we violate the rule that we just showed, right? Okay. Now what? So now you know that this is actually what we call a homomorphism between groups. That's abstract algebra. And then you've got something that comes down here, x1 squared plus x2 squared plus xn squared. Well, what is this right here? What is the sum of the squares inside of a square root called? That is, yeah, I heard that. Was that you? It came from over there. JP. Is you, Sarah? Okay, what about the square root of a squared? And before you answer this question, I want you to take a deep breath. Thank you. What's the square root of a squared? Yeah, thank you. If I had $1 for every time somebody told me that it was a, I could pay for one of you to go to Stanford for 4 years. Yeah, go ahead, Eamon.
So do we apply this only to 1x? What if we had like multiple, like, what if we had a y2 or like a y column vector? Do we only do like this, like, do we do the same process like that? I don't know if you get my question.
I don't yet, but you can train me.
X a times the scalar multiplication of x and y. So let's say we have the same.
You're talking about like this?
Like a y dot, almost like two. Do we do the same thing?
Like that?
Yeah.
Okay.
Do we do the same? Or
I'm not ready to answer that question because I think that we need to do some What did I say? Every single time you write down an operation? Every single time you write down an operation in this class, what do I want you to do? Dimension analysis. Every time you look at a map, what do I want you to do? Just look at my stupid face and remember a song that I played for some of you. Where did you come from? Where did you go? Where did you come from? Cotton Eye Joe. Okay, maybe we should do that for the 2 norm. Where am I going? That one needs to go first, or what? Anybody still working on this board?
Yeah, we are.
Yeah, okay, so then. Let's do a quick dimension analysis here. All right, let me ask you this. If we're looking at the 2 norm as a map, so recall, the 2 norm is going to be a map between what we call a domain and a codomain. That's why I have you do this in 1C, you do it in my 1D. Every professional mathematician in their right mind, in my opinion, when they see a new function, they're going to ask themselves a few questions. What is the flavor, what is the behavior of that function? What type of input does it have? What type of output does it have? What is the size of the input? What's the size of the output? When I'm having you sing that dumb song, well, it's actually kind of a catchy song. I guess it's a lot of bar mitzvahs have that, is what I've been told. Right? Is that true? Where did you come from? Where did you go? I had a student tell me that was like at every bar mitzvah he'd ever been to. Anyways. Yeah, right?
I'm sorry.
Yeah. So every single time we look at this, I want to know, what does it take in? What does it come out? And the reason I want to do that is I want to train you to think through your own questions. When you ask me that question, my claim, the answer to that question is in a dimension analysis. With that said, Emin, I would ask you this. What size input do you expect based on the definition of the 2 norm? What do you have to put into a 2 norm? Vector. What type of vector? Column vector. So what would the input be? Where did you come from? R n by 1. What does that immediately tell you about the size of the input to every 2 norm problem that you'll ever get in this class? Must be a column vector. 2 column vectors? 1 column vector. Okay. What's the size of the output? I'm not asking what the actual achieved output is. I'm asking what the size of the output is. R. Is there a difference between the codomain and the range of this particular relation? For example, if I defined a function, remember that the only way that I can talk about the words codomain and range is if I have a function. Well, let's define a function. What's the range of that function? Yeah, we just said, well, be careful. It's R non-negative. What's the difference between non-negative and positive? Nothing. Not a damn thing, right? 0. He's like, that's not funny, Anderson. You lost your chance to laugh, man. Yeah. What's the codomain of this function? They're different, right? When I write this map, what does it tell you immediately about that operation? It tells you the number of inputs. How many inputs do you have? 1. What size is that input? N by 1. What's the type of output you expect? Is it vector valued output or scalar valued output? You can read that just from that map. Now, your question to me when you said, let's consider, this is a beautiful question. Do you ever break stuff just to see how it works? Emin, honestly?
Always.
Yep, I can see that. Keep doing that. That's a great, you're an engineer?
No, musician.
You're gonna make me want to turn you into an engineer. You keep that up, man. You like to break stuff just to see how it works. All right, let me ask you this. If you were to do this, if you did A something X something Y, what's the size of the input? It's a scalar. Which means that the 2 norm in this case, you could just look at an absolute value. Because this is now the 2 norm. Yeah. Did you notice that the absolute value is the 2 norm in R1? Did you see this? You know this? That if I take the absolute value of A, this is A squared square root. It's the sum of the squares of this vector A. Yeah, the 2 norm is the first instance, the absolute value is the first instance of a 2 norm that you ever see in your education. We just don't tell you, oh yeah, by the way, there's more fun stuff underneath, right? Because we don't want to scare you away. Okay. So formally speaking, you got to be a little careful. What type of input does a 2 norm expect? An n by 1. How many? It's unary. It's not binary, it's unary. The inner product, on the other hand, let's do this for the inner product. So this is what we call the 2 norm. Let's do it for the inner product. Boom. What does the inner product expect in? What does the inner product expect out? Inner product's domain is Rn cross Rn. What's the codomain? R. What does that mean immediately? This is a binary operation because it has a left argument and a right argument, and the sizes of each argument must be identical. In other words, I want a column vector and a column vector, and when I take the inner product, what do I get out? If I want to use the words range and codomain, what must I do before I use those words? Define a function. What would the function be in this case associated with the inner product map? X inner product y. Then I could say that the domain is Rn cross Rn, and then I could say that the codomain is R. This habit is going to be useful for the rest of the quarter, and I'm going to have you do this. Sometimes I don't write it on the board, but you know what my expectation is now that I've been harping on this for 15 minutes today, and I'm going to harp on it for the rest of the quarter. Do you know what my expectation is every single time we do an operation in this class? I don't think you can dance like that to that song, but if you want to try, that's cool. Yeah, all right. Did I answer that question?